good stuff. So just as a recap, so that we get back to sort of as a catch up from where we left off last time, we talked about why it's important when you're running these moderation analyses, why you can't look at actual moderation effects with just a straight regression. Okay, within your standard simultaneous regression, there's no way to test whether or not sort of different levels of one variable impact the relationship of another variable in your outcome. Mathematically, you just can't do it. So what we need to do is start building in multiplicative terms, and these are our interaction terms here. Okay, and so remember what we had done with this is we had two hypotheses, right, regarding moderation. We had said that what we expect or what we were looking at is the impact of pain severity on the relation between PTSD and functioning, okay, and the impact of opiate use on the relation between pain and functioning, okay. Connor, in these models here, what are my two moderators here?
Pain and opiate.
Pain and opiate use, and what are my two conditional effects that I'm looking at?
Functioning and I can't remember what the N one is. I can't say it.
So they're both functioning. So those are the outcomes. What are the conditional effects, or what are the moderated effects that we're looking at in these two hypotheses?
The effect of PTSD on functioning and the effect of pain on
functioning, right? So your two conditional effects are PTSD and functioning and pain and functioning. Okay. So here you've got a situation where pain is a moderator and pain is also a conditional effect sort of within this model. Okay. Now remember that your interaction terms are symmetrical, right? I could frame this as PTSD as a moderator of pain and functioning. I could use this as pain as a moderator of drug use and functioning, right? What you really need to do is understand like what's the way that's most sort of conceptually, theoretically consistent to think about these. And oftentimes this will be based on, you know, if I've got a large history that says PTSD is related to functioning, then that's probably going to be my base relation, right? What I'm interested in is just pain, does level of pain change this, right? So in this situation, I'm modeling PTSD as my conditional effect and pain is my moderator. Okay. Same thing here. We know pain is related to poor functioning. That's not the numbers, right? And so what we're doing is saying like, well, does opiate use moderate that? Does it lessen the relation between pain and functioning? Okay. Really important as you're setting these up to make sure that you've identified what's my moderator and what's my conditional effect, because it's going to impact how you go through and restructure these equations. Okay. So remember that what we're going to do is we're going to take our full equation that we get from SPSS and we're going to restructure it to make these conditional effects apparent. And so what we're going to do is with restructuring this, what we're going to do is we're going to first just pull down your intercept. That's the easiest way to do things because, you know, that's just nothing's attached to that. Okay. And then I'm going to pull down anything that doesn't involve one of my conditional effects. Okay. So here, my conditional effects are PTSD, my conditional effects are pain. So I'm going to go down through and I'm going to pull any term that doesn't have in it PTSD or pain. And the only thing here is just this opiate, right? So I'm going to pull that down. Okay. Then what I'm going to do is I'm going to go through and bracket off my two conditional effects. Here's pain, here's PTSD. And now I'm going to start just pulling things down to go through and tease these out. Okay. So I'm going to start with pain. I'm going to say, okay, here's a pain term and here's a pain term. We got pain term here, but that's also tied in with PTSD. So I'm going to set that aside for a minute. Here's pain, here's opiate and pain. I'm going to just pull these down and restructure this, right? So I can see now that when I spin this out, the unique effect of pain on functioning is going to be dependent on whatever I put in for opiate use. Okay. Same thing, pull the remaining terms down for PTSD. And so I've got here my conditional effect of PTSD, and I can see that that coefficient is going to be dependent on whatever I've set pain equal to. And so now once I have my restructured equation, I can go through and see with this that the effect of pain on functioning is going to depend on whatever I plug in for opiate use. The effect of PTSD on functioning is going to depend on whatever I plug in for pain. Okay. Always, always, always when you're doing this, once you factor your equation out, multiply it back out again and make sure that you get back and arrive back at here. If you don't, something's gone wrong. Okay. Also be very, very careful about your signs and making sure that those are carried down too. That's another easy mistake to make with this. Okay. All right. So then what we do is we can go through and calculate our simple slopes by hand, right? And here what we're doing in this first one where we got PTSD as my conditional effect, moderated by pain. Pain is a continuous variable here, okay? So what I need to do is I need to decide what constitutes high pain versus low pain. And what's our default in these situations? What do we generally set as high pain and low pain? Or high levels of our continuous variable and low levels? Standard deviation above and below. Is there anything unique or special about a standard deviation? No, but it's a metric that we know and we understand. And you can say, you know, if you're about it, if we have a normal distribution, if your standard deviation above, like a sort of like in the 30th something percentile, right above, and it just makes for a decent, a reasonable sort of point estimate of that high point. Also, we generally expect a decent amount of our sample to be existing out there at one standard deviation above, right? We could say 5 standard deviations, but is that a real value that represents anybody in the sample? Probably not, right? So standard deviation above and below makes some sense. So here, once we've centered pain, we've got a standard deviation above. This is another thing that centering makes nice, right? If the mean is 0, standard deviation above or below is just plus or minus the standard deviation value. So we've got high pain is 1.34, low pain negative 1.34. And so for high pain, we just go through and plug in our value of 1.34 for pain. So here's my restructured equation that I pulled out, right? Anything that has to do with opiates, that's being held constant at 0. So those go away, right? So I've got, here's my reduced equation here. And I'm just going to plug in for high pain, a value of 1.34. Okay, drop that in for pain, multiply this out, and what I get is my simple slope for the conditional effect of PTSD on functioning at high levels of pain. Okay, take note of that language because this is going to help you give you sort of words for what we're talking about here. Again, my simple slope here is giving me the conditional effect of PTSD on functioning at high levels of pain operationalized as a standard deviation above.
Can you repeat that language?
Yeah. So I'm saying that this is, if we want to talk in formal statistic terms, talking about sort of this simple slope represents the conditional effect of PTSD on functioning at high levels of pain. So again, holding out everything else in the model constant, what we're seeing, this is a unique effect of PTSD on our outcome for people if we're looking at high level, conditioned on high levels of pain. Then for low pain, easy peasy, we just take our reduced equation and just plug in negative 1.34. Okay, that's where we've got low pain. And if we spin this out, again, what we're going to get is the conditional effect of PTSD on functioning at low levels of pain operationalizes the standard deviation below the mean pain. Okay. So what we can see is that this conditional effect is different, right? Here it's 0.04. Here it's negative 0.42. Now, do we know if these are interpretable, meaningful, sort of anything along those lines? No, but can we calculate out the math and get this out? Absolutely, right? All right, do people sort of, this is kind of a refresher, people seeing that kind of the logic behind this? Yeah, April.
I understand it once we break it up into this one moderation, like the interaction between PTSD and pain. I think what I'm confused about is how on the last slide, that really big equation had 2 moderations in it.
Yeah.
I think I guess my question is, do we have to split it up this way in order to find the simple slopes?
Yep,
Okay,
you do. What you wouldn't want to do is just run a model, and then we talked about this last time. What you wouldn't want to do is run a model with just one interaction and then run a different model with the second interaction in it. Because if your idea is that pain and opiate use are both serve as moderators in the context of this relation, if I don't put in the full model, I've got a misspecified model. I'm not accounting for everything in this, right? And so what you need to do is have everything in here, right? And so you can start to see if you start to have 3, 4 interactions, some 3-way interactions, how complicated this gets, right? So you want to be careful, but you want to make sure that you've gotten everything in there that you want to have in there, okay? The nice thing about this, April, with centering is anything that you're not focusing on is generally set to 0. If we set something to 0 in this, what happens? It all goes away, right? And so that's where things are falling out. The math works nice with centering. Do you have to center? No, you don't. But if you're going to do this, it's really, really nice because it makes things easy. Okay.
so for the whole model, we would need to put both moderators in at the same time because that's how we specified it.
Yep.
But when we calculate our simple slopes, we set what we're not looking at to 0.
Yeah, exactly.
Okay, thank you.
Exactly. Yeah. Okay. And so the same thing, if we go through, so we set up our conditional effect of PTSD, we can also then sort of go through and pull out our conditional effect of pain here, right? And so again, here's my reduced model that we got sort of, or my restructured model for before, right? But here what I'm looking at is the conditional effect of pain on functioning for people who are using opiates, who are not using opiates, right? What am I not concerned about in this model? What do you think, Lucy?
Not concerned with PTSD.
I'm not concerned with PTSD. And if I'm holding PTSD constant, what do I hold it constant at?
0.
0. And so it goes away. So anything related to PTSD is gone now, right? So now I'm just left with this component of it. April, does this make some sense?
Yes.
Okay, right? And so now what I'm doing here is I'm going to look at the conditional effect of pain on PTSD for people who do and don't use opiates, holding PTSD constant at 0. And if I'm holding PTSD constant at 0 in this centered model, what am I holding PTSD constant at? The mean, okay? This starts to become really critical in making a determination on sort of does my model sort of fit the way that it's supposed to, and are things okay? So we go through, and here, and this, again, I can't emphasize this enough. So opiate use is that dichotomous variable, it's coded 0, 1. But we went and centered it, but because it's evenly split, no opiate use is negative 0.5, opiate use is 0.5. If I don't have an even split, it's not going to be 50-50, okay? So you can't just go through and take a dichotomous and code it negative 5 and 5, because unless it's a perfect split, you're going to be off, okay? Just keep that in mind. So what we're going to go through is go through for no opiate use, throw a negative 0.5 because that represents our people who are not using opiates. And I get my conditional effect of pain on functioning for people who are not using opiates, holding PTSD constant at the mean. Right? And then I do the same thing, plugging in 0.5, I get my conditional effect of pain on functioning for people who are using opiates, holding PTSD constant at the mean. So a lot of things to go through and keep track of in your brain as you're working through this, or people kind of following the process. Yeah, Lucy.
If we don't have an even split
Yeah.
on a dichotomous variable, how would we, like, could you give an example of how we might like set the values and how we didn't interpret that?
The exact same way you would go through and do it with a continuous variable. Literally, if you take the average, if you take the mean of your dichotomous variable and just subtract the mean from your, it gives you exactly right. And I'll show you how we would do this, right? So even for, it makes, it doesn't seem like it would make sense to subtract the mean from a dichotomous variable. But if you do, it's going to give you the right answer with that. So you just get the code. It could be 0.33 and negative 0.33 and positive 0.66, or sort of negative 0.25 and 0.75. It works out perfectly. It's easy. You don't even have to worry about it. All right. So then, what we do here is we go into Excel, plot out our simple slopes. We talked about this and again, talked about the interpretation of these starts to become really, really important. Remember, like circle this, star this, write this down. When we're working in these regression models, we're not looking at mean differences. We don't care about mean differences, okay? These lines that we've plotted out are just predicted associations. They're not even real associations, right? It's just our model's best guess at what this effect of X on Y would look like at different levels of M, okay? So what I would do is if I was looking at this top panel here, what I would say, these points right here are just points to give Excel something to graph, right? And so what I would not do is go through and try and compare these 2 points, right? Or this point and that point, because that's not the process. Would be like an ANOVA type of situation. Here with continuous regression, what I would say is, boy, based on this plot, it looks like that there is a stronger negative association between pain and functioning for people who are not using medications versus those who are. Okay. And does this make sense given what we're seeing here and how, in theory, opiate medications should work? Or you're shaking your head, yeah? Why does that make some sense conceptually? What's that? Oh, that's all right. Why would this make some sense? So we're seeing a weaker relationship between pain severity and functioning for people who are taking pain medications. Does that make some sense?
Functioning and pain. Wait, sorry. Say that again.
Yeah. So we're seeing a weaker, not necessarily a weak, but a weaker relation between pain and functioning for people who are taking medications versus those who aren't.
They're taking medication.
Yeah, right. So is their level of pain still related to functioning? Yep, it sure is. But it's less tightly connected than for people who are not using pain, right? If I'm an advocate for opiate medications, I would probably be pretty jazzed about this. I'm like, all right, it's not fixing everything, but it's making things a little bit better, I guess. At least there's not such a strong relation between pain and outcomes here, okay? So again, what we're doing is we're focusing on the association and not at the levels, right? Here, and this is where we started getting sort of turned around with stuff. Because I would say like, well, for people with high levels of pain, people with opiates are functioning better than those without opiates. And for low levels of pain, people who are functioning or not using opiates, that's not the way to go, right? Because these are just I don't even know if there's anybody who actually exists at these points. These are just projected values. These are just a random points on a continuous estimated line, right? And also, do I know if these are meaningfully different from one another? One exists higher than the other one in physical space, but there's nothing to say that speaks to anything about sort of like expected change in things. I have a paper where I did actually do that, and you can sort of rig the equation or rig the regression model and go through and test that with some overlapping confidence bounds and things. But that was just because there looked like some weird stuff that was counterintuitive. I just had to do that to rule that out. To be like, hey, this is not a way to interpret this, right? Yeah.
So if you like wanted to get those exact differences, we can just go through and do like contrast tests or.
Yeah, I can show you how to do it if you're interested. Basically what I mean is recentering your model so that this is your intercept. And then if that's your intercept, you get a confidence bound around that point estimate. And then you do recenter the model so that that's your intercept. And so then you can go through and start to look at overlapping confidence intervals for stuff, right? But again, it's really, really dicey and it's not something we would normally do because these are not actual real observed values. These are just points on a continuum, right? So for everything we do, just focus on the association, okay? Same thing down here, right? If I was looking at this, I would say that, well, it looks like for people who are low in pain, there's a negative relation between PTSD and functioning. As PTSD increases, functioning decreases for people with low levels of pain. For people with high levels of pain, what's going on here? What do you think, April?
I think that functioning is low regardless of PTSD because they're in high levels of pain.
Yeah, high levels of pain. These are people who are just miserable, and it doesn't matter the level of PTSD, they're just not functioning well. Now we see a little bit of an upward slope here, right? What do we make out of that?
It's still bad to have high PTSD, but when you're in a lot of physical pain, it's not. Oh, actually, I don't know.
Does it seem likely that PTSD is a protective factor for people with probably not, right? What I'm guessing is that there's maybe not an effect here, but I don't know. It's positive. I might want to go through and check, right? So we're going to hold that and think about how we go through and address this. Okay. So again, just remember we talked about when we go through and plot this out, and remember these are using data that have some weird skewed distributions on my outside, on my output. 0 is the floor for this scale. So I've got a whole lot of stuff that's existing below, right? And this is not necessarily terrible, right? Because these are all just kind of predicted values. But know that sort of these are not literal observed values. Otherwise, it's saying my projected value or at a standard deviation above pain, a standard deviation above the mean of pain for someone who's not using opiates is a functioning score of -5. Is that real? Nope, it's not, right? So just wanted to keep this in mind that these are just model implied associations, not actually what's happening and going on in your data necessarily. Questions about this? Was this helpful in kind of getting people back up to speed, sort of the general thought process and things? Okay, cool. So again, what we're going to go through, plot these in Excel, go through and read through this. This is just basically setting up little tables to go through and plot this out. Okay. The thing I would just make sure that when you're doing this, that your conditional effect is on your x-axis, because sometimes it'll plot it backwards, and then you just need to flip it around in Excel. Okay. So here's the situation. So everything we've done up to this point, which is pretty amazing, we can do with just a little bit of algebra based on our full model, right? There's nothing we need to do. We don't need SPSS for any of this stuff, okay? The problem is sometimes when we're probing these conditional effects, it would be nice to get just a little bit more information and be able to sort of sharpen our interpretations here, okay? So if I have a non-zero interaction, right, in my overall model, I found evidence of an interactive effect. This tells me that the unique effect of x on y changes over other values of my moderator, okay? If I have that interaction term, if that is registered as significant, right? That's evidence. We have evidence, and maybe not strong evidence, right? So we've been working on this for a while, but we at least have evidence that whatever my base variable is, that the effect of that on my outcome differs depending on what this other variable is. Okay. Now, what this doesn't give me is an extent to which we have non-zero effects at a standard deviation above or below. Okay. I know based on my results of my model that I can say with some level of confidence, right, that yes, in fact, pain moderates the relation between PTSD and functioning, and that opiate use moderates the relation between pain and functioning. Okay, but what I don't know is whether or not. So what's the actual p-value for that slope? What's the p-value for this? And here, what's the p-value for this? It looks like this is a positive slope, right? Does it mean the PTSD is a protective factor, or is this just sort of random error stuff like that? We're not able to pull this out of our base model. Okay. So again, what we're going to do though is we can go through and start to hijack the math of our regression models to go through and actually test this. And this starts to become very, very important in sort of clarifying what's going on with this stuff. Okay. So to test our simple slopes, here we've created our simple slopes. We've estimated our simple slopes, but we haven't tested our simple slopes, right? Because we've just done this with a bunch of hand math. Okay. So what we want to do is we're going to go through and do a couple modifications of our multiplicative model here. Okay. So remember, like, let's take our first question here. We say, what is the impact of pain severity on the relation between PTSD and neural functioning? What I'm gonna do is in my syntax, I'm gonna rescale my moderator to create two new variables that correspond to high and low levels of my moderator. Okay, so in SPSS, what I'm going to do is I'm going to create a new variable. And this new variable is going to be called high pain. Okay, and high pain is going to be equal to my pain value minus 1 standard deviation. Right, so I know that in my centered solution, pain has a standard deviation of 1.34. So what I'm going to do in order to create my high pain variable, I'm going to take my pain score, my centered pain score, and I'm going to subtract 1.34 from everybody in the set. Okay, and then I'm going to create a second variable called low pain. For low pain, what I'm going to do is I'm going to subtract a negative standard deviation, which means I'm going to take my centered pain score and I'm going to add 1.34 like this. Are you going to ask me why I'm subtracting things for high and adding things for low?
Yep.
Yep. Okay, Lucy, you gonna ask me the same thing? This is counterintuitive, all right? But if we think about what we're doing, let's take a look. So let's say here's my centered pain score, right? And here, case number 23 is dead center. They have a score of 0, okay? So my mean is 0, my standard deviation is 2.3 in this. Well, we won't call it pain, we'll call it something else, okay? People see what we're doing, so here's my centered score. If I go through and I subtract a standard deviation from every score in that centered distribution, okay? So here my mean is 0 and my standard deviation is 2.3. If I go through and I subtract a score of 2.3 for everyone in the distribution, what happens now is my person who was at the mean of my distribution, who was at 0, if I subtract 2.3 from everything, what's that person's new score? Is negative 2.3, okay? Did my standard deviation change? No. My mean is now negative 2.3 because I subtracted 2.3 from everything. Emma, where is 0 now?
0's ahead of where your mean value is.
0 now represents a standard deviation above the mean. So if I center everything at a score of 0, April, what am I centering things at?
Oh,
High
standard
levels.
deviation above the mean.
Right? Same thing if I go through, if I add a standard deviation, right? So here's my centered variable. Here I subtract, here I add a standard deviation, right? Case number 23, what's their new score? Is 2.3. Where does 0 exist now? A standard deviation below. Okay, so this is counterintuitive. If you go through and plot it out, it makes sense. You're like, oh, I see what's going on. But the math is weird because what I do in order to achieve a variable where 0 represents high levels of pain, what I need to do is I need to subtract a standard deviation. And if I'm creating a new variable where 0 represents low pain, I need to add a standard deviation. Okay. I would very much love for you to understand sort of why this works. But if you don't, if you just accept it and know that if I need to go through and get high levels of my moderator, I subtract. And if I get low levels, I need to add. That's also fine as well. Okay. Does this clarify kind of what's happening and why this works the way it does? Okay, go back through Lucy and plot it out, right? And so think about like, okay, here's my person at 0. If I go through and I subtract a standard deviation or subtract a standard deviation from every single score in the set, that person who was 0 is now negative, whatever the standard deviation was. That's still the mean, but where is 0 now on that distribution? That distribution sits at a standard deviation above.
Oh, because like these are different, like there's two separate simple slopes.
Yeah, exactly.
Okay, that.
Exactly.
Yeah, okay.
Okay. So what we're then going to do, so now we've got two new variables in our set. One that represents where 0 represents a standard deviation above the mean of my moderator, and a second variable where 0 represents a standard deviation below the moderator. Then what I'm gonna do is I'm gonna create 2 new interaction terms corresponding to these conditional values of my moderator. So I'm gonna create an interaction term called high pain times PTSD. It's gonna be my high pain variable times PTSD. Then I'm gonna have a low pain times PTSD that's gonna be my low pain rescaled variable and multiplied by PTSD. Okay. So what I've got now is I've got 4 new variables in my set, right? I have a variable for high pain, a variable for low pain, and then I have an interaction of high pain by PTSD and an interaction of low pain by PTSD. I have 4 new columns in my data set for this. And then what I'm going to do is I'm going to analyze separate regression models for these continuous effects. So what I'm going to do now is I'm going to have, again, if we're just focusing on the one effect, right? I would have any point in my model where there's pain, I just take out pain and I plug in my low pain variable. So now I've got my intercept, low pain plus opiate plus PTSD plus opiate times low pain plus low pain times PTSD, and run that. Okay. Here, this coefficient for PTSD, this is the unique effect of PTSD at low levels of pain now. Same thing, and then I would run a separate model. What I would do, I would swap in high pain. Any place where pain was in my original model, I just substituted my high pain variable. So now I've got my intercept, high pain plus opiate plus PTSD plus opiate times high pain plus high pain times PTSD, right? So I've got new interactions for both of these that I've gone through and swapped in. Okay. And again, my simple slope here now is giving me the unique effect of PTSD at high levels of pain. See how we set this up to test these simple slopes. Yeah.
You see like how we set it up to find that specific coefficient and why it's different at low pain levels and high pain levels. How does this help? I guess I'm confused. How does this tell us if it's truly non-zero?
Okay, hold on to that. So what I'm going to do is I'm going to run 2 separate regression models. I'm going to run a regression model, and basically, April, what I've done is I'm running the same regression model as I did before. All I'm doing is in my base model, where 0 corresponded to the average levels of pain, I'm rerunning a new model where 0 now represents a standard deviation above the mean of pain. And I'm going to rerun that model, right? Because if we go back through and we think about okay, here's our model in our base model that we ran, right? What this is looking at is the effect of opiate use on my outcome, holding everything else constant at 0. Okay, holding everything else constant at 0 means average levels of pain, average levels of PTSD, and the conditional effect of pain on opiate use at sort of at average levels in controlling for opiate use and average levels of pain and PTSD, right? As I go through and take this, and so then go through and take a look at my say simple slopes at low levels of pain, what I'm going to do for every place in this equation where there is a pain term, I'm going to take mean centered pain and I'm going to throw in my rescaled variable where 0 now corresponds to a standard deviation above pain. So now I've got effective opiate use control at average levels of PTSD and a standard deviation above the mean of pain, right? This is the effective PTSD, expected value of PTSD, controlling for opiate use because that's split at a standard deviation above pain. This is the interaction at a standard deviation above pain, interaction at a standard deviation above pain, right? And then I'm going to go through and I'm going to run a second model, or I guess a third model at this point. And I'm going to substitute in my low pain, right? So now 0 corresponds to a standard deviation below pain, the mean of pain. So now this is the effect of PTSD, holding everything else constant at 0. But holding everything else constant at 0 means controlling for opiate use and pain at low level at a standard deviation below the mean of the sample, right? So all we're doing is we're just playing around where that 0 point is, right? But what we know is as we go through and we do this, right? What we see is that where I go through and I sort of put that 0 point for pain, it's going to impact sort of my coefficient for PTSD, right? And the same thing as I go through and I change what 0 means for opiate use, right? That's going to impact my effect on pain, right? So all we're doing is we're just playing with math here. This is just algebra. I'm just changing what the meaning of 0 means because my model is always going to run, here's the unique effect of X on Y holding everything else constant at 0. What we're doing is we're just playing around what 0 means. And by doing that, we can start to tease out a number of interesting effects. And if you understand this, this can be very, very helpful and sort of essential for understanding what I'm testing and starting to build different models. So we go through here, we go through create low pain, high pain, relevant interaction terms, and now I test this model and I test this model, okay? And here's what I get, right? So with my, just my straight additive model, here's my uncentered solution and here's my centered solution, okay? Do I see any differences in these models? There's one difference. Elena, what's the one difference?
Intercept.
My intercept. Why is my intercept different?
One, it's centered, so it's based on the mean, not like at 0.
Yep, exactly right. The only thing that changes across these centered and the uncentered models with a straight additive, like our basic regression model, the only thing that changes is my constant, right? Because my constant represents the expected value of my outcome, holding everything else constant at 0. Well, here in my uncentered solution, 0 means no pain, no opiate use, and no PTSD, right? So my functioning is expected to be decent. Here in my centered model, what this is saying, this is the unique effect of, or the expected value of my outcome, holding everything else constant at 0, but my centered solution now represents the average of sort of the balance of opiate use and non-use, average levels of pain and average levels of PTSD. And if you look at your constant, it's much lower, right? Because we're talking about a situation with much more pathology, right? But we don't see any changes in any of our coefficients because in our straight additive model, it doesn't matter what I hold those other things constant at. So the unique effect of X on Y is always going to be the same. Okay. Yeah, Connor.
Sorry, could you say the interpretation of the centered constant one
Yeah.
more time?
Think about it this way. Okay, the interpretation is always going to be identical. You're just plugging in what 0 means, right? Your constant is always going to be the expected value of your outcome, holding everything in the model constant at 0. Okay, well, what you know in the centered solution is what 0 means for those different variables means a different thing than what it is in the uncentered solution. Okay, here 0 means no pain, no opiate use, and no PTSD. Here, it means average levels of pain, average levels of PTSD, and kind of the split between the opiate use and non-use. Okay, kind of the average of opiate use. So the literal interpretation, the base interpretation doesn't change. Regression models are always going to give you unique effect of X on Y, holding everything else constant at 0. It's just what happens when we start changing what 0 means. And we start rescaling our variables, and then we can start to tease out more specific effects. Does this help? Now, if we go through and take a look at our multiplicative models, okay, again, comparing our centered solution and our uncentered solution, model summary is identical, right? Nothing changes. I can center this, I can not center this, it doesn't matter. Sort of the overall contribution or accounting for the variability of my outcome is exactly the same. My ANOVA table is going to be the same. Nothing changes here. Okay. But what we do start to see are changes in my coefficients. Okay. So in my unstandard solution, right, what I've got, here's my constant, here's my effective or here's my centered solution. Let's go back over here. In my uncentered solution, I've got my constant, right? Which is my expected value of my outcome isn't even real on my scale, right? It's a higher value that you can achieve on this, right? So again, speaking to the benefits of centering in terms of sort of interpretability of my model, right? But here is the unique effect of pain severity on outcome at 0 levels of PTSD for people who are not using opiates. Okay. For opiate use, this is the unique effect of opiate use on my outcome for people who have no pain and no PTSD. And here's my unique effect of PTSD on outcome for people with no pain who aren't using opiates. Do people see how I got those interpretations in my uncentered solution? And if we go down through and we take a look at your interaction terms here, your interaction terms, these are going to be the identical across. Your interaction terms aren't going to change across your centered and your uncentered solution. But your conditional effects sure are, which makes some sense because when I throw in these interaction terms in, it's saying that the unique effect of X on Y is going to change depending on what I go through and put in terms of my other other variables here. Okay, so if I go over and I take a look at my centered solution, here's my constant, right? This is the expected value of X, my expected value of Y for people at average levels of pain, average levels of PTSD, we say controlling for opiate use, okay? And you can see it's much lower, right? Here we've got the unique effect of pain on functioning for average levels of PTSD, controlling for opiate use. Here's the unique effect of opiate use on functioning at average levels of pain and average levels of PTSD. This is the unique effect of PTSD on outcome at average levels of pain, controlling for opiate use. And if you go through and you can see all of our lower order effects here are all different. They've all changed, right? But this makes a lot of sense because these are all conditional effects. Because all 3 of these terms are involved in interactions, right? And because of that, because we've modeled those interactions, we would expect these lower order effects to change depending on where we've centered our other variables. Okay. Now, in this situation, we'll call this interpretable. We'll call this an effect that we can go through and, it's 0.051. We'll not worry about that. We'll just call that an effect here, right? And so you've got two evidence for 2 interaction effects here, right? And what we can say is, not knowing anything else, we can say, well, it looks like the effect of pain on outcome changes depending on opiate use, and we have evidence that the relation between PTSD and outcome changes across levels of pain, right? By definition, because we have evidence here, right? But what that means then is that these lowered effects, these conditional effects, are going to start changing depending on where we set that 0 point. Okay. Now this will happen even if, let's say these weren't, let's say this is 0.237 and 0.612. Okay. Right. Would we still expect these lower effects to change across the centered and the uncentered solution? We're saying my interaction terms aren't significant. I don't have evidence of moderation. Would I still expect, though, mathematically these coefficients to change? Yeah, exactly right. Why is that, April?
Because you're still, like, regardless of how significant it is, you're still changing where 0 is. So the number would still be different.
Yeah, exactly. The numbers are still going to change, right? So even though these are sort of very clearly not something that would be interpretable, these are still going to change across these, right? So you have to be very careful and planful and thinking carefully about when you're running your base model, what do I actually want to test? Okay. And this starts to become relevant for, as we'll see in terms of opiate use. If I have a dichotomous moderator, right? I'll often still center that on the front end just to kind of weigh the average of this. It just makes this base model a little bit more interpretable. And then if I have to go back through and test to see So that if there is a moderation effect, then I just have to kind of recode some things. That's fine. I'd rather just for the first time, just center those dichotomous variables, just to kind of interpret that my base model is kind of on average across these things. Okay. Now, the one thing you'll see here is that who haven't I picked on? Danielle.
Yes.
Look at your collinearity statistics, your tolerance, your VIF. Are you seeing differences across your centered and your uncentered solutions here?
Yeah.
Yeah. Which one looks ugly and which one looks fine?
The uncentered one looks a bit ugly.
Yeah, the uncentered one looks a lot ugly, right?
Yeah.
And so this is one of the things historically that have been argued. One of the benefits and primary benefits of centering, in addition to interpretation, is it addresses collinearity in your variables. Okay, what happens because your interactions are a function of your base term, right? What can happen is you have like really high level correlations between your interaction terms and your base effects. And what you see is those will show up in some really messed up collinearity diagnostics. Okay. And so the argument is because when centering goes through and changes and starts to change your covariance, it starts to go through. And what it does is in the centered variable, those collinearity diagnostics look a lot better than they do over here. Okay. Now, from a practical standpoint, this does nothing to any of your coefficients. It doesn't mess with them. It doesn't change anything. And so folks like Hayes will throw a fit about sort of people making an argument that you have to center, right? And he's a brilliant person and he's right. It doesn't make a difference in OLS types of situations. But if you start creating interaction terms with other estimators, maximum likelihood, stuff like that, this will crash the hell out of your program pretty quick, right? So you want to go through and say, and I would still say the benefit of centering is that it improves interpretability. And that just makes it a good thing to do. Okay. So from here on out, you should always assume that you should be centering your predictors. Do you need to center your outcome? No, you don't need to center your outcome. That doesn't sort of change anything, right? Just your predictor variables. Okay. So again, if we go through and take a look at your centered correlations, uncentered correlations, you've got some moderate correlations between your predictors. But here in your centered table, your centered interactions only sort of moderately to not at all correlated with one another. If you look over here in your uncentered solution, you got some really high correlations between things. Again, for OLS regression, it doesn't actually make that much of a difference, right? But just know that centering will go through and make your collinearity diagnostics look a lot better than they would if you're using an uncentered solution. Also, if you're not centering, calculation of simple slopes is more of a pain in the ass too. It's just easier to center things off the start. But if Hayes ever reviews one of your papers and tells you don't need to center, you beg, fair enough, bro. But I did, so I'm not saying you have to. So, all right. Effective centering on your simple slopes here. Okay. Here's your full model. Okay. Here's your constant centered pain, centered OPU, centered PTSD. Right. What you see is your interaction terms. These coefficients don't change at all. Okay. What you will see though are changes in your constant, changes in sort of OPUs, changes in PTSD, right? Because what we're doing is we're switching around where your pain variable is, and opiate use is involved in interaction with PTSD. PTSD is opiate use is involved in interaction with pain. PTSD is involved in interaction with pain. So we expect if I start shifting around where pain is, these coefficients are going to change as well. Okay. Now within this, the simple slopes for low pain, simple slopes for high pain, what is the coefficient I'm most interested in here? I think if I'm interested in the conditional effect of PTSD at low and high levels of pain, which one of these coefficients is my simple slope that I'm interested in? What's actually the only p-value and coefficient I'm interested in these submodels?
For high levels of pain.
Yeah, so the conditional effect of PTSD at high and low levels of pain.
So like high pain PTSD variable.
Yep. And
It's at high pain,
at high pain and what else?
at low pain.
At low pain, right? You're gonna go through, you're gonna set these models up and do a whole bunch of stuff. The only thing you care about in terms of interpretation is that coefficient and that coefficient, okay? So what we're looking at is that what's the p-value associated with that, okay? Also take a look, thinking back, what do we get for the conditional effect of PTSD on functioning at low levels of pain? Negative 4.13, or 0.043, right? These should be the identical coefficients that you calculated by hand within some rounding error. If they're not, something's gone sideways. Okay. So all we're doing here is here's our base model, right? And we found that we have an interaction of pain and PTSD. And so what I want to do is I want to look at the conditional effect of PTSD at low levels of pain, conditional effect of PTSD at high levels of pain. So what I do is I go through and I run a new model where I just sub in my low pain variable for everything in here. And then I just go through and I take a look at my conditional effect for PTSD. And here I've got a very small p-value, right? Run a separate model, substituting in my recentered high pain variable. Go through, only thing I'm interested in is my coefficient for PTSD. Like my p-value here, it's very large. We don't have any evidence of effect right there, okay? Nothing else in this model I care about outside of just double checking to make sure that my things turn up right, okay? Other thing too, you'll see that when you do this, the coefficient for your moderator will be identical across these two, okay? The unique effect of pain on outcome doesn't change across these two solutions. Okay, what will change are your other lower order effects that are involved in an interaction term, but your interaction terms themselves, those aren't going to change. Okay, this starts to become an incredibly important slide, knowing what should change and what shouldn't change, because this is how you check your model to make sure it's doing what it's supposed to be doing. Okay. You should not see across your base model and your two simple slope models, your interaction coefficients, nothing on that should change across those two. Now, if you had a three-way interaction, then your two-way interactions will change and your three-way interaction won't. But here where we just have two ways, these interaction terms, identical. If they move or if they're different, something's gone wrong. You need to go back through and figure out where things went backwards, okay? Your moderator, doesn't matter where it's low or high, that should be identical. That shouldn't change at all, right? If you have lower order effects that are not involved in interaction, let's say that I controlled for sex or gender sort of in this model, but if that's not contained within an interaction, will the coefficient for the unique effect of sex gender on outcome change across these models? Nope, because it's not included in an interaction, okay? What will change is any coefficient that's involved in an interaction that's not your sort of moderator that you're shifting around. Okay. People get it, and again, I can't, like, you will foul this up. I continue to foul this up, right? Just because it's a lot of moving pieces and parts. What starts to become critical is being able to go through and say, hey, did I go through and did I do this correctly? If this is the pattern you're getting, thumbs up. If it's not, you got to go back through and figure out where you got something sideways. And these coefficients that you're getting for your simple slope, these should be identical to the ones you calculated by hand. Easy peasy, no different, right? If they're not, either your hand calculation is backwards, you ran something wrong here, you need to go back through and check. So it's a complicated process. The nice thing is there's lots of fail checks to go through so you can determine, you'll know whether or not you got the right answer, the right model before you turn in any problem set. Because if you did, this will work out. If you didn't, it won't, right? So just sort of be attuned to that, okay? Questions? All right, where are we at in terms of time?
9 time, 3 time.
10, okay, cool. Let's jump in to our actual data set and take a look at what this looks like, actually like working through in your syntax file. Okay. So we've got here I opened up I literally just took like our handout and pasted in so the commands into this syntax file just to kind of speed some things up a little bit. So this is what we're doing with this, but so we've got and we've already screened these data, right? So we know we've got full information for pain, opiate use, PTSD, and neural functioning. Okay. So if we go through and pull up and you're sort of following our handout, the first thing that we're going to do here is we're going to center our variables. So what I'm going to do is I'm going to just go through and I'm just going to run descriptives for pain, opiate use, and PTSD, right? This is easy enough. This is just gives me sort of my descriptors for each one of these. Okay. And what I'm going to do then where the screen's adjusted here. Looking back in the Stone Age, I don't got my screen. It's like I said, 7 feet long. Put a real cramp in my style. I don't like it. All right. So what I'm going to do then is I'm going to go through and in my syntax file, I'm going to go through, and you can do this through the pull down. I'm going to go transform, and I'm going to compute, right? And I'm going to say, I'm going to call this centered PTSD, right? And this is going to be equal to PTSD minus whatever I'm seeing the mean of PTSD being. I'm saying mean is 4.0702. They go for 4.07. Seven two. Oops. Okay. So there, and I'm just creating my new PTSD, my center PTSD variable. And I'm just going to go ahead and hit paste, right? You can see it right down there. Okay. So I'm just going to do the same thing for PTSD, pain, and opiate use. Okay. If I go through and I take a look at, we see some question about sort of that dichotomous variable. All I'm going to do is I'm going to just look at the mean for this dichotomous variable, and I'm just going to paste that into sort of whatever the my dichotomous variable is minus the mean of that, and that's going to center that perfectly for me. Okay. And so in your actual output, you can even go through and just, double click on the mean and paste that in if you want to. That's sort of easy enough, right? But what we're seeing here in my syntax file is that I've just gone through and created these 3 new variables here. So I've got centered pain, centered opiate use, and centered PTSD. See what we did there? Questions with any of that? Okay, so what I'm gonna do now is I'm gonna go through and I'm gonna run this. And we can see in my data set now I have a variable for centered pain, centered opioid use, and centered PTSD. Following along with this procedure up to this point? Okay. So now what I'm gonna do is I'm gonna go through and sort of hear what I've done. Oh, so before you go through, once you've centered your variables, always go up, run your descriptives, and run descriptives for all of your centered variables, okay? Take a look at what you get. That is why we do this, okay? Did I center things correctly here? It's probably impossible to see. Nope, I sure did. Something weird's going on, okay? It looks like something's going on with my PTSD variable. I'm missing someone there. If I go through and I take a look at my mean is not exactly 0. Something went sideways there. So let me go through and pull up my data set for PTSD. Oh, there it is.
Yeah, that's what I was gonna say.
What's-
Use the wrong mean for PTSD, use
Okay.
the one for pain.
Yeah,
Oh, well, here, I think what's gone on with this is I have a missing value for SD. So what I did, and I took is that right?
wait, I think the 4.0
Oh.
value,
Is for pain.
that's the mean for pain.
You use.
Oh, that was a
And
big.
that was for
Yeah.
PTSD.
Okay, gotcha. Gotcha.
Correcting that myself here.
Okay, here, let me go through. I'm gonna do this, try this again. You can get rid of that. My one person who's missing PTSD score, and we'll get rid of that person. Are you not missing someone with PTSD? Are you not missing someone with a missing PTSD score?
It's not coming up for an issue for me, but I am getting that my centering
missing
for opioid use is negative
.0025.
Is that normal?
That's,
Because
and
it's
here's,
dichotomous?
yeah, let's go through, if you go through and you look at analyze and go to frequencies for opiate use. Is it exactly 50-50? No, right, so we got a rounding error there, so that's gonna be what's going on with that. Okay. So let me go back through here and rerun this once I actually.
So for that like rounding error, at what point would that become like concerning?
Sorry, did you say?
Probably not. Not. Here's my efforts to make things, so work. Efficiently, probably failed, so let me go through and try again. Connor, with that, it's one person in a sample of sort of 200 some people. It's not gonna make a difference. If you want to get super precise, just double click on the mean of opiate use and it's gonna be 4.9, something out there, and then just drop that in. Yeah. Okay, so there we got this. Moderation. Must have deleted somebody here. Okay, so we go up descriptives. Pain. Opiate use PTSD. Go through, take a look. What I mean is 4.0702.5. Okay, that's I accidentally sort of deleted something in the set and got it turned around. Connor here. If you go through and you double click on this, it's actually 497, something like that. You can go through it and adjust that. So, okay, so now if I go through and run this, and then I analyze descriptives. There we go. Okay, there we go. Now, if you, it works out if you don't accidentally delete values out of your set, okay? But again, sort of, you know what? I did that on purpose, 100%, just to sort of make a point to demonstrate the importance. Even I screw up centering on occasion. So just go through and always make sure that you go through and do this because it's just a nice double check with this moderation stuff and all of your analyses. It's all about double checking, going back through, making sure that you got stuff figured out. Okay. So now we've got our centered variables appropriately sort of set up in our model. We know that the values, the mean values are exactly 0. And what I did here is I just ran through and ran an additive model, centered and uncentered solutions. Right? But we talked about it. We don't need to worry about that. Okay. What I am going to worry about now, though, is I'm going to go through and I'm going to create my interaction terms. Okay. And I know that what I want to do is I want to look at the conditional effect of PTSD on outcome at different levels of pain. I want to look at the conditional effect of pain on outcome for opiate users and non-users. So I've got 2 interaction terms I need to create, right? I need to create an interaction of PTSD and pain and opiate use and pain. So what I'm going to do here is I'm going to create 2 new variables in my model here. I'm going to compute P times PTSD. This is going to be centered pain times centered PTSD. Then I'm going to look at opiate by pain. And this is just going to be my centered opiate times my centered pain. Okay. We'll see how we're setting these up. Like we are very literally manually creating new interaction variables for our data set. So when we go through and we do this, go through and run this, and then if I look at my regression or at my data set, I see I have a variable for pain by PTSD and opiate use by PTSD, and these were my centered variables. If you run into problems and things aren't squaring the way they should in terms of your numbers, make sure that you've gone through and created your interaction terms from your centered variables. That can sometimes foul stuff up if you don't do that.
Do you want to try the syntax again?
Yeah.
Thank you.
It's just, again, just asterisk is the sort of multiplicative there. And Lucy, again, it's on your handout too that you've got there as well. Yeah, this makes it easier to see. Yeah, Emma.
Is the reason behind running the regression prior to creating your interactions just to look at like the change across your zone?
That was just a didactic.
Okay.
You don't need to worry about that. Was just to kind of see kind of what's going on across centered and uncentered solutions. Okay. So what we're going to do now then is we're going to go up and go to analyze. I'm going to go to regression, linear. So I'm going to start going through. I want to look at my outcome is still role function. Do we screw around with role functioning at all? Nope. We just leave that alone. Okay. But what I've got is I've got centered pain, centered opiate use, centered PTSD, centered opiate or centered pain times PTSD, centered opiate use by PTSD. Okay. I throw those into my independent variables. Go to statistics. I want the descriptives, part and partials, core linearity diagnostics. I need to worry about plots or saving anything here, right? That's all for screening stuff. And I'm going to go ahead and hit OK. Okay. So what you're going to get is your regression model that we had already taken a look at here. Okay. And so you can see always in this base regression. Work down to make sure that you understand what these coefficients are, okay? Here, my constant, this is my expected value for role functioning, holding everything constant at 0, which means average pain, average PTSD, and sort of controlling for opiate use, okay? This is going to be my conditional effect of pain. This is the unique effect of pain on functioning at average levels of PTSD, controlling for opiate use, right? My coefficient for opiate use is the unique effect of opiate use on functioning at average levels of pain, average levels of PTSD. My unique effect of PTSD on outcome at average levels of pain, controlling for opiate use, okay? And then here I have my interactions, okay? Always go through, make sure that you give me an interpretation of your interaction. Here, p-value 0.002. I say what I do is I have evidence for that the effect of PTSD on outcome is conditioned on pain, right? And here I see an interaction of opiate use and pain that is close enough, right? And what we'll say is that we have evidence here that the unique effect of pain on functioning looks like it's at least potentially dependent on sort of opiate use. Okay. In the presence of these interactions, you know you have a moderation effect, that you know you have interpretable conditional effects. What we need to do is now go through and tease those apart and see what's happening with stuff. Okay. People comfortable with this? And here your 0 part partial correlations, these are the same thing as they've always been. So going down through next, and now we go through and we plot these out. Yeah, Connor.
Conceptually, I think I'm just having trouble picturing it right now, but for the interaction terms, how do you like
Interpret the actual coefficient?
Yeah, like zero. Okay.
Don't worry about it. You can. That's a high level, that's a high level move, right? So don't worry about it. So don't worry about trying to give me like a per unit 8. Don't fool around with that. Like you can do it. It's not worth it sort of working out. Like once you get this all mastered, and if you want to go back through sort of look at that, don't worry about that for right now. Okay. So again, please don't in your write-ups say, oh, for every unit increase, and then the interaction changes. No, that's not what's going on with that. Don't give it a literal interpretation of that coefficient. Thank you for reminding me about that. Okay. So what we're going to go through and do is we're going to restructure your equations just like you did before. Here's the effect of PTSD on functioning at high and low levels of pain. Okay. And so now, and then also if you want to see what my simple slopes graphs look like, it's easy to just set up here, right? What I've got is I've just got my simple slopes equation plugged into here, and then my values for high and low pain PTSD, so I can swap stuff out there. Makes that pretty simple. Right? So what I want to do now, though, is because I've got my unique effect of PTSD on outcome at low pain, my unique effect of PTSD on outcome at high pain. What I want to do, and I already know what my simple slopes are, right? They're negative 0.413 and positive 0.043. What I want to do is I want to test those. I want to attach a p-value to those, okay? And this is where we're going to go through and start sort of playing around with our model. So let's go through, this is a good break point. Let's go through, let's take 10, come back, and I'll show you how to start setting up recentering or rescaling your moderators to be able to go through and take a look at stuff. Okay. All right, cool.